Okay, in the last video, I showed you how to make a 1, 2, 3 block from scratch. This video, we're going to machine it in 3-axis mill. Let's get started with switching from design to manufacture. We'll right-click Setups, go to New Setup, and when your little window pops up, you're going to want to scroll down to Setup, Operation Type, click on that, and go to Milling, which changes from whatever else it was on to milling. You have options of milling, turning, mill turn, cutting, or additive. We don't use any of the other ones. We're just doing milling right now. Okay. Here's your chance to change your work coordinate system. I always tell it which way is Z. So click on the first one, Z up. And let's go to stock and tell it from solid. That's the solid we want to use. Let's go back to setup. And we'll tell it that the top of this surface is Z0. X-axis is along this line. That's fine. Let's just flip it over. Sometimes it does that, sometimes it doesn't. That's how our part's going to be sitting in the machine. Let's tell it that our stock is a relative size box with 0 on top and maybe 100,000s on the sides. We got that backwards. 0 on the sides, 0 on the top, not 0 on the sides. 100 on the sides. Stock side offset, stock top offset. Okay, that means that we have 100,000s all around this part, nothing on the bottom. Now, let's tell it that our stock is going to be 250 on the bottom. And let's say we're using some real little talon jaws. And the jaws got a little step with the teeth on the bottom. Okay, hit OK. And now since we're making this from scratch, let's go to facing. And I don't believe I have a facing tool for a 1/2-inch end mill, but let's see what we have. Create from template. We could use a 2-inch cutter, a 2-inch fast feed face end mill. Tool number 1. Right click and edit it. Close chain. We don't know what we're doing here. That's going to be our chain for geometry. Machining type is 3-axis. Bottom height says selected contours 100,000s below. We want that to be 0. And this is actually an adaptive toolpath. We want it to be a facing toolpath. So we hit OK. We get some little weird geometry or toolpath. What we want to do is right click on that operation, go to derived, go to 2D milling, and go to face. This is our facing path. This is derived from our previous toolpath. So our stock contours are there. Our Z0 is model top. Top height, I always do selection. All that other stuff is just annoying. We go to selection for retract height. And clearance height, also selection. That way you have more control over what's going on. Top height, it's going to be 10 thou above. Retract height, we'll put it at 300 above. So you got a clearance height of 400, retract 300, feed height from 200, which is way too high. Let's go to 100. Okay. None of the rest of the stuff matters. No depths. We just want one cut. Hit OK. Now we have a path that does this. I like to tell it to that the stock is a little bit bigger than it really is, so that it makes a better path. So I go to stock offset and I tell it that it's half an inch bigger. Now I feel like my toolpath is covering more. Now let's delete the old stuff, the first toolpath, and we'll just keep the facing. That's fine. Maybe it's a little longer. You can adjust it to yours. That's great. From here, all we have is a facing program. Let's go to simulation. You can see our model underneath the stock. You can see there, it just faces it. Let's X out of there. One thing that looked weird on that toolpath is that step over was a little small. Well, let's go with 1.75. That's much better. Okay, now right click on the setup. If you haven't already built your tools for your templates, you should start doing it as you go. Things will get way easier and much faster. You'll make programs way faster every time. All of my tools are in the cloud. I want a 1/2 inch end mill that does contouring, but I want adaptive clearing. I don't want to set every tool height or step over axially. I want the adaptive toolpath to do it for me. Right click edit on your tool. It thinks it's doing pockets. It's not. It's doing contour. The gray blue area is our stock. We want it to go down to our selection here. Right there. Bottom height -105. Our load is 50 thou. Minimum cut radius 50 thou. Stock to leave 20. Yeah, that's fine. I don't want anything on Z. Okay. My speed and feed's already set. 250 surface feet. 1.5 thousandths per tooth, which, since this is going to be like a non-heat treated D2, we can probably keep it around 2 thousandths. Let's change this one. Let's just make that an even 11.5 all the way down. All right. Hit OK. Now you get a toolpath that the software Fusion 360 will make the optimum toolpath, keeping your 50 thousandths sidestep. So you have this. And right now we'll do a simulation much slower so we can see what it does. And it picks up those little corners. Yeah, you can adjust that. You can maybe make the side cutting a little bit bigger. That way it doesn't have to go in there and pick up those little things. A little bit of tweaks here and there will fix everything. Hit OK. We're OK with that. So now we have the top surface finished. The sides with 20 thou on them. What I'll do is come in here. You never want to use the roughing tool as the finishing tool. You have to have a second tool. Most managers will be like, why do you need 2 end mills? One's a rougher, one's a finisher. The finisher that is there separate will be much more consistent than using a roughing tool for the finishing tool every time. Some people who are not real machinists will not understand that. For me, I have tool 5, finish end mill, 1/2 inch end mill, same thing. All of my stuff is already set. I'll select the bottom contour just to save myself some time. 50 thousandths below that bottom. Hit OK. That's it. 35 seconds to do that. Speeds and feeds, pretty much the same thing. A little bit of faster feed rate. That's okay. Alright, so now we have 5 sides complete. And we want to put these 15 holes in there. Again, make your tools, save them in the template. For me, tool 3 is very common. Number 3 center drill is tool 8 on my machine tool list. Click edit, right click edit, select the hole faces. What are we doing here? Center drilling all these holes real quick. My speeds and feeds are already set. It can be a little faster for you. This is maybe D2 will go a little faster. 2,000ths per rev is fine. Doesn't need to be anything extravagant. You can tweak it yourself. For me, this is what I use. Hole faces. And I use select same diameter holes. Maybe it's not working. Take it off. Clear the face. We'll select them by hand. And that is okay. Press OK. We are going down to our heights. Everything here is already set from previous. All we do is machine down 100 thousandths just to get a little bit of start. You can see our path starts in here in the red. 1, 2, 3, 4, 5, 6, 7, all the way to 15. Exit right here in the green. What does it look like in the simulation? There's our face tool. 2 passes. There's our roughing end mill. There's a little cleanup that we can fix later. Here's our finish pass. Center drill all the way across. Great. Take that center drill. First, let's measure this hole here. Right here at the bottom, that's a 391 hole. So let's right click, center drill, duplicate, edit, press the tool, and we'll make a tool. I go to user libraries. All of these libraries are already downloaded from Fusion's tool libraries online. Use them, download them, they're good. 391, doesn't come up. 390, nothing. 397 is letter extra. Okay. What is that? We can use a 397. And we'll tell it that we're going into high carbon steel. Everything that we already selected is already there. Only thing we have to do is deselect some stuff. We don't want to oversize these tapped holes. So we'll hold Command or hold Control on your Windows. Select all these threaded holes or deselect them. We want to change our height. Roll your part around. Go to the bottom height. Go to selection. Select the bottom surface. Okay, and now you want it to drill through the bottom. Right there, you can see the drilled holes go through the bottom by 100 thousandths. You can change that to 50 if you think it's going to save you, 5 seconds, whatever. Press OK. That's great, except our tool is tool 2 instead of tool 9. In my toolpath, in my tool library per machine, most of my drills are tool 9s. So I'll change this to tool 9. Letter X drill. Make a better note of that. Letter X drill. Point 397. If you don't put it in there, your operator's never going to know what it is because they're never going to look at the chart. Tool 9. Press accept. Select. I don't like that feed rate. Let's change that to 4. 2,000s per tooth. Press OK. What do we do different? Right click, edit. The last tab in linking. Second to last tab. That's a new tab. We're going to cycle. We want this cycle to be a G83. So we'll go to deep drilling, full retract. We'll make that 60 thousandths per peck. Press OK. Now we're good. This little note here with this 15 minutes for drilling that, which is crazy long, we'll change that for ourselves to a 397 drill. Alright. 15 minutes seems kind of long for that. It's not like it's stainless steel or something. Let's go a little bit faster. We'll go with 60 and 5 per revolution. Nine minutes. And we'll see. And when you're drilling this, some D2 is softer, some of it's a little gummy. We'll see how it is. That's a decision you have to make at the machine. Alright, so we have that. Now let's go and chamfer all of these holes. I have a save tool for that. It says a 1-inch chamfer drill. It's not. It can be any chamfer drill that's 90 degrees that's larger than the hole you're making. It doesn't have to be anything different than that. Maybe it didn't come up. Let's go back. 1-inch chamfer drill. Select. There we go. Number 14. Edit. We don't know what we're doing here, so let's select what we need. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. If you're using a 90 degree tool, you can write 2 chamfer or chamfer diameter. I will press OK here, even though it's incomplete, because I don't know what size the chamfer is. If I select the circle, look here at the bottom right, it says 451. Right click, edit again on the tool, go to your heights, and that number, 451. Now let's change our cycle to rapid drill out. That's fine. Press OK. Now all of our tool paths go to that size right there. If you're a true 90. Now nothing's perfect in real life. When I run this tool, I pick it up 25 so I can measure it later. Alright, let's do the next one, which is a radius of 188. Okay. Now right click on that chain chamfer tool, duplicate it. Right click again, edit, and go to heights. And instead of doing the math in my head, just type in 188 times 2. Except we want to select the other holes. this one, here, 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 and here. 5 holes. Done. Gravy. 6 minutes to chamfer all those holes is probably long. Again, D2. D2 will be a little bit tough than steel, a little bit harder to machine, but not like some Hastelloy or something like that. Alright, so let's do one more thing. These are, I believe they're 1/4 20. But let's try and figure out what size they are. Let's go to the top. And let's go back to design. From scratch, new sketch, top surface. And I want to drop it right there in the center of the hole. Fusion will give you a circle when you're in the center. Click there. And for some reason we're in metric. That's a 7.5 millimeter hole. Let's change that. Let's see, metric is 7.5, 7.5 divided by 25.4. It's a 295 hole. Okay, whatever that means. We're making it 1/4 20. That's probably a 5/16 18 hole. We'll do 5/16 18. Manufacturer. Alright, let's go back to tool 9. We'll duplicate it. We'll edit it. We'll go to tool select. 5/16 is 312. Let's go with let's scroll down. I don't remember all by bat. I want to say 5/16 is 281. So let's go with 9/32. High carbon steel, select, and we have to change which holes we're drilling, so that's pretty easy. We'll just highlight the ones we need. Here, here, there, last one right here. The path goes all the way through. Press OK. Okay. Edit tool. I just want to change the tool number. This is an old computer, bear with me. Press OK. Alright. So we got center drill, tool 8, center drill, tool 9, tool 10, chamfer all the holes. Next we want to tap only those 5 holes. So I would right click on those, duplicate that path again, instead of making it from scratch. Save everything you can do. Right click that duplicate, edit, tool select, user libraries, up here in the top, 5/16. Everything with 5/16 will pop up. I want 5/16 18. Press select. That's probably too fast of a feed rate, so I'll go to 125, or spindle speed 125. Change the cycle. You want right hand tapping. That way you get a G84 and an M19 in your CNC, so that you can go back in the hole if you need to. Although I would double check before I did that. Press OK. Taps all the way down. Probably needs to go a little bit deeper. I would push my drills deeper before I push my tap deeper. That's up to you. You have to do that at your machine, not me do it for you. I'll edit that and probably go 200 deeper. And negative 200 deeper. Press OK. Go to isometric view. Right click. Edit tool. Now this tool is tool 16. Press OK. Done. I tap everything at the end. Drag your operation down to the end. Now we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 operations for 29 minutes. That can be tweaked to go faster. This is just a preliminary program. Let's go to simulate. Back out a little bit. Press play. Here's our machine tool simulation. Finishing, center drilling, drill. We don't have to watch all of these drills back. We're skipping the other holes. They're a much smaller hole. You don't want to drill out your threads. All the chamfers, separate chamfers, and tap in the last 5 holes. That's it. For your other sides, you could do the same thing. Copy this program. You know, in your head, you're machining this before you even get to a CNC. Take that. Right click this whole setup here. And you can duplicate that. Okay. What do you need on this side? Edit it. Change that Z face to that one. Press OK. You want to face this other side, except you're not taking 250 thousandths off in one pass, so you're doing multiple depths. 50,000 step down is great. The top height, okay. We're selecting the wrong face. We're checking that face. This face, same one. Clearance height, same face. Hit OK. Now you get one path. Let's change this feed height to 250. Top height is 0. Now let's change it to 250 as well. Alright. Press OK. Retract height must not be below. Let's change this to 1 inch. Let's change this to 400. Top height. That's what's wrong. Selection's wrong. Alright, now everything is black. Press OK. Now we should get a few toolpaths here. That's fine. Second side. Do you need to machine the outside? No. You need to finish the outside? No. All your holes should be all drilled already and tapped. You do want to keep the chamfer there. Let's delete those. and delete the tap. Alright, now we're on the back side, so everything is mirror image. You don't even have to do all of this in Fusion. You could have just copied the other program, added more paths to the facing tool, and deleted all the tools like I just did, and you would have been in the same position we're in right now. No whole face is selected. Now let's do that. 1, 2, 3. There, 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 and there. Press OK. Those two paths look fine. Right click. The next one. Edit it. It thinks it wants to do it from the other side because this is a copy on the other side. Now let's just select the last few things to do. I missed one. You will still have to go in here manually and clean these tap tools out. There's no getting around that. Some people are just like, oh, I tapped it or I chamfered it already. Yeah, no. Alright, so now you got the top and the bottom. The sides, easy to figure out. You can't do the sides until the top and the bottom are machined to have a square surface. I hope you like this video. If you want to see me talk about anything in Fusion that you haven't seen here, leave a comment, like and subscribe. Have a good one.